All right, on this video, we're going to do identify a transformation based on coordinates or algebraic rules, and we should be able to figure out what's going on there. Um, I tell my students this all the time. You don't have to memorize these rules to figure out what's happening. And if all else fails, we can make a graph, and then we should be able to figure that out like that. But what we're going to do is we're going to start with the first one. I'm not worried about the dice roll. I just use this because it's nice and neat. So we go from the first one where it says original to new. Well, I know x plus 10. This is the only one that does plus 10 is my translation. So this tells me that I'm translating uh, right to the right 10 because x plus 10 is right. And then up 5. Okay. If I weren't sure about that, I would take a point like say 1 comma 3. It's a rule of thumb to take not even numbers to check on your graph and plot them and see what happens. So x plus 10 would be 11. So 1 plus 10 is 11. And 5 plus 3 would be 8. So this would be my new spot if I had to graph that to see what would happen from my original to my new. Okay. The next one, we have x comma y for my original, and then my new is negative x comma y. So this tells me x changed and y stayed the same. Okay, if x changed and y stayed the same, remember it's in the name, y stayed the same. It's a reflection over the y-axis. Okay, to double check that, you would take a grid or a graph point, and I'll show you what I mean by graph. This graph isn't the cleanest, but what I would say is I would take for x comma y and go to negative x comma y. If I took that point 1 comma 3, so I go over 1, so 1 comma 3, 2, 3, and then I say x becomes negative, well, negative 1, and y stays the same, comma 3. That is literally a reflection over the y-axis. So it's going from here to there. Okay, so that's visually how we would check that. So this went from 1 comma 3 to negative 1 comma 3. Okay, so when in doubt, we can always graph and see what's going on. So we know that, and I wrote the points 1 comma 3 on my graph, and that became negative 1 comma 3. So we could see what happened. When in doubt, grab your grid. You can Google centimeter grid paper. You can Google star sheet graph paper. You can buy some from Walmart, but that's really helpful when we're doing this type of work. So the next one, we have x comma y. That's my original, and my new is here. This says x stays the same and y changes. Okay, well in this case, the only difference between these two is which one changed. So this is probably also a reflection, but I think this one is going to be over the x-axis because the x stayed the same and the y changed. So if I had 1 comma 3, this time it would be 1 comma negative 3. Okay, if you were to graph that, let's go ahead and erase some of this. If my point is 1 comma 3 and I'm reflecting, so this is negative y this time. Okay, see if I can get that to focus a little bit better. There we go. Negative y, I would say x stays the same, but y becomes negative. So 1, 2, 3 goes down there. So this is 1 comma negative 3. Okay, so we can see how it reflects over this axis this time. So once again, when in doubt, graph. Because I know it can be kind of confusing where I'm just looking at the algebraic letters. Okay. All right, next one. We have original, we have new. I have xy, and then it says x and y switch places and y or x becomes negative. My memory from this would tell me that it's probably a rotation of some sort because when x and y switch places, it's a rotation. So we're going to say rotation. We're going to see what kind of rotation in just a second. So I'm going to say, let's take that same 1, 3, and for it to x and y switch places and x becomes negative, that says that y would be in the front, 3, and then comma negative 1. Okay, that's what the rule says over here. So let's see what kind of rotation that is. So I'm going to bring my graph back. We have 1, 3, and we said that the new graph would be 3, negative 1. So 3, negative 1 would put me right here. So this is 3, negative 1. So it went from here to here. That is one turn, which would be 90 degrees. Okay? So we are going to go confirm that over here on this page and say that a rotation where it goes y, negative x is a rotation of 90 degrees, and this is clockwise. Okay? Next one. We have x, y, which your original is your new, and we go from x minus 2 and y minus 1. Well, up top, we already know that plus and plus tells you right and up, which is a translation. So this is also a translation. Okay, we know that left is negative, so we're going to say left 2, and we're going to go negative y, which is down 1. So if I had to pick the same thing, 1, 3, I like to use the same point to start with because it makes it where I can see how that original point would move with all these different rules. And that would become left 2. So x minus 2, so 1 minus 2 would be negative 1. Okay, and then my y minus 1 would be 3 minus 1, so that would be 2. So it would go from 1, 3 to negative 1, 2. Okay, so we've covered almost all of these. The last one is x, y to negative x, negative y. This one, if I go from 1, 3, and I end up with negative 1, negative 3, I'm pretty sure this is a 180 degree rotation, but we can double check. So let's do that right now. So I've done 190 degrees. So let's go ahead and just double check. If I do negative 1, negative 3, oh, well, this puts me here. This is negative 1, negative 3. If I were to turn this 2 turns, this would go back to positive 1, positive 3. So if I do that, just so you can see, that's counterclockwise. So now I'm at negative 3, or 3, negative 1. And then if I rotate this again, I can see that I now, where I was at negative 1, 3, am at 1, 3. Okay, so that rotation is just, this one is also now at negative 1, negative 3. So that proves that that was indeed a 180 degree rotation. So remember the rule for 180 degrees that tells you that both sides, x and y, become opposite. So this is a 180 degree rotation. So we finished up that. Once again, if they gave you a rule such as this right here, we can figure out what all of those rules say by taking a point, putting it on a graph, and manipulating it to see what happens from the original point to whatever the new thing is telling me to do. Okay? So hopefully that helps. Once again, be sure to like, comment, subscribe, share if you want to. Hopefully this helps. Be on the lookout for more content. All right, thanks. Bye-bye.